Hi everyone, this is Mohammed and today we'll be developing an agentic project that will serve us as a writing team. So here's the scenario. Imagine we have a writer agent and a critic agent. The writer agent produces a piece of text that might not be necessarily high quality, and the critic agent provides feedback for the content, the grammar, and the style of that text. And these two agents engage in an ongoing conversation until we have a high quality, well-written piece of text. And I previously recorded a similar video with Autogen, and you're more than welcome to watch that video if you're interested. But this time I'll be doing it with OpenAI Agents SDK. So let's see. Okay, so we'll be doing most of our stuff with the Agents module provided by OpenAI. It has a bunch of functions and classes that facilitate the agentic project development. So right now I'll be using the agent class with capital A. This class represents an LLM agent that gets some instructions, can produce text, can use tools, and so on and so forth. So let me introduce the writer agent. It's an agent, it can have a name, and we'll see what is the use of this name. In the end of the video, I will log the agent flow with the trace. It's a dashboard provided by OpenAI. So we can see this name appears in that dashboard. And it gets a set of instructions. So you are a writer agent. You will be given a topic and you will write about it. And you will receive feedback from a critic agent, and you will revise your writing accordingly. Okay, this is good enough, and I can also specify which model I wish to use. So a suitable model for our application is O3 Mini. It's both powerful and cheap, and yeah, this is good. And let me also introduce the critic agent. So it's another agent. The name is Critic. And here's the instructions. You are a critic agent. You will receive writing from the writer agent. And you will provide feedback. Good. Okay, your feedback should be on the content, the grammar, and the style. And for each aspect, you should provide a brief to-do list and an integer score from 0 to 10. Okay, so we have this one. Oh, sorry. I'll use this O3 Mini as well. And okay, I should also specify my OpenAI API key. So if you don't have your API key, you can easily get your API from platform.openai.com. You can go to the settings. We have an API keys tab here. Well, you see, here's my API key. If you don't have one, you can create a new one here. And as the term secret says, please don't reveal it to anyone else. And be careful not to push it to your GitHub repository. And okay, and there's two ways you can introduce your API key. You can either export it as a system variable, or you can keep it in a separate file. And you can use this function, set default OpenAI key. So set default OpenAI key, and I should enter my OpenAI key. So open API.text and read it, and make sure there's no space at the end. So this way I've introduced my OpenAI API key. And just to show you how to work with an agent, let me ask the writer to write something. Okay, so in order to make the agents work, there are usually two ways. We can either do it synchronously or asynchronously. Generally, the preferred way, I guess, is the asynchronous way, because, you know, in this kind of application, working with an agent is an IO-bound process. It means that our processor, our CPU, is not gonna do most of the work. Instead, we'll be waiting for OpenAI servers to respond to our request. So instead of just waiting there and doing nothing, we can do other tasks, usually in larger projects. That may not be really the case in this project, but it's a good trait to get used to this kind of coding. So I'll also need a runner object. This runner object can run my agents asynchronously. And I also need to import the async IO. That is the asynchronous module in Python. If you're not familiar with async IO or its syntax, don't worry about it. As long as you know what is happening in this video, you're good to go. But, well, I strongly encourage you to go and learn about it afterwards. Okay, so I need to define a coroutine. So I say async def main, and let's say this is my prompt. Write an email to my professor, let's say John, and ask him for a time so that I can see my exam paper. Okay. So I want to feed this prompt to the writer agent. Here's what I can do. I can say await runner.run, and, you know, as suggested by the documentation, it gets a starting agent and an input. So the starting agent will be the writer agent, and the input can be either a string or a list of T-response input item. If you don't know what this is, I'll talk about it momentarily. But for now, just let's pass a string, our prompt to run, the run method. And of course, it returns an object. Let's see. It returns a run result, and here's the writer. Oh, let me just make it brief. Our result, and I can then print it to see what is this object. And in order to run this coroutine, I can say if name equals main, async io.run main. So using this syntax, async io.run, I'll create an event loop, and in this event loop, I will be executing the main coroutine, and inside this coroutine, I will await the runner.run. It means that the processor will wait here and make sure we have the result, and then go on. But you know, the advantage of using async IO metaphor or async IO way of doing this is that in many different applications, we can have multiple agents that they're not dependent to each other. They can run at the same time or almost at the same time. So I can gather all of them and run them using this way. I can, instead of, let's say I have 10 agents, and each agent can take approximately 10 milliseconds. instead of waiting 100 milliseconds, I can wait around maybe 12 or 13 milliseconds, and all of those 10 can run simultaneously, but approximately simultaneously, because they will be run in the same core, in the same thread, but it doesn't wait for each of them, but it tries to do most of the work simultaneously instead of waiting stall. So I guess I can run my code now, Python writing.py. Okay, so let's see. Here's the run result. Last agent, I've just worked with one agent for now, and this agent has no access to other agents, so the last agent will just be the writer agent. And here's the final output. Here's the subject, here's the email, and I have some other arguments. We'll get used to these arguments in the next videos as well. But okay, and I want to show this more clearly. So I can just say the final output part of W result. And now I will only see the email. Yeah, you see. Okay. So this was one way to work with an agent, to pass it a string. The other way is to pass it a list of t-input response param. So let's see what that is. Okay, let's go to the documentation, and let's go to the runner. Okay, you see, when you call the runner .run, it returns a run result, and the input can be either a string or a list of t-response input item. And if you go to t-response input item documentation here, it says that this is a type alias for the response input item param type from the OpenAI SDK. We can just go and see what this is. So let me search this in OpenAI SDK GitHub. So yeah, this is their GitHub, and you can go to source OpenAI, and there's this types folder, and you have responses, and this is input item. What was it? Let me check again. Response input item param. So let's find it. Response input item param. Okay, so if you take a look at this file, we have a bunch of data classes, and in the end we have this response input item param, which is a type alias for all of them. So for example, if you take a look at the message class, it gets, and all of these are type dictionaries. A type dictionary is just a regular dictionary, but it's not dynamic, it's static. And I mean, it has predefined keys and types for their values. So for example, here you can see that this message class, it should have a content, a role, these two are required, and two other optional keys, status and type. And so for example, we can pass a dictionary that has only these two keys, content and role. And you see, for example, the role can be either of these values, but in their agentic module, they will also use the assistant role as well. So let me go back to the code. So instead of passing a string, I can create an input list, and I can say, okay, the first item is going to be a dictionary. It has a role, and the role is user, and the content, which is the prompt. And now instead of passing the prompt, I can pass the input list. You see, it worked again, no difference in the output. And, after executing this runner.run, I have this W result, and inside this W result, let's go and check the documentation again. It also returns the input list that has the output appended as well. So here's the runner, here's the run result. You see a bunch of methods. One of them is new items. It just returns whatever output that was concatenated to the end of the input items. Or we can also get, we can also get two input lists. This is another method. It creates a new input list and merges the original input with all the new items generated. And again, you see the type is a list of two response input items. So if I want to make sure I have the most recent context, the most recent chats, and all the chats, I mean the history from the beginning to the most recent one. So I can say, I can update my input list. I can say my input list is wresult.to input list. So here the input list will be this one, the prompt, and the answer of the writer agent. So right now I need a loop, and inside that loop, the writer comes up with something, and then it passes it to the critic, and the critic agent provides the feedback, and we have the next iteration, and we go on until we're satisfied with the result. So let's create a while loop, while true, and I shouldn't forget to specify the breaking condition. So initially, in each iteration, I called the writer, I passed the input list, and in the first iteration, the input list is just this prompt, and then I can say writer output will be this one, and then I will update the input list, and now it's time to pass it to the critic agent. So again, C result is runner.run critic with the input list, and after the critic returns its response, I'll say print the final output of the critic, and I will also update the input list. I must do this so that in the next iteration, the writer gets access to the feedback. And just to make sure I can see each step, I'll insert a press enter to continue here to stop it after each iteration and see what is happening. Okay. You see, writer comes up with a text, and here's the feedback. Below is the feedback for content, do this and this and this, and score is 9 out of 10. For grammar, everything's all right. And for style, you can see the score is 9 out of 10. So then the writer should revise its text according to these scores and these to-do lists. So again, now you see that style has improved. The grammar is again 10 out of 10, but the content is still 9 out of 10. It's good enough, but they can go on forever because I haven't specified any breaking condition. So again, you see, again 9 out of 10 for content and 10 for grammar and style. But let me stop it. So now I need to specify a breaking condition for the while loop. And let's say my breaking condition will be that all of the scores are above a threshold. So, okay, I can specify a threshold and check all the 3 scores for grammar, for content, and for style. But I need a mechanism to access those scores. Right now, those scores are inside a string, and well, there are some ways to extract them. For example, I can use regex, the RE module in Python, or I can just search for a score and keep whatever number comes after it, even without the RE, but those are not the clearest ways of doing it. So, we have a very good option in the agents. We can specify the output type. So I can create my own data structure, my own data class, and I can pass it to the Critic agent and ask it to return the output in that structure. So I'll be using the data class from data classes, import data class. And another option will be to use Pydantic, but for this video, I'll be just using data class. I'll have a class, I'll call it feedback. And what do we need in feedback? We need a grammar to do. It should be a string. We need a content to do. We need a style to do. And then we need grammar score, content score, and style score. And these will be integers. And I need to decorate it with data class. Otherwise, it's my duty to implement the instructor, the representation method, and other relevant methods. So right now I have a data class. This is just a structured class that is specifying what keys, or what fields I have and what are the data types. So I will pass this to the Critic agent. I'll say, okay, output type will be feedback. So from now on, the Critic agent will return a data structure in the form of feedback, and I can work with that easily. So I would say, threshold is gonna be, for example, 9 here. And if, just before doing this, let's see the final output. I would like to show you how it looks. Okay, this is the writer response. And yeah, this is the Critic output. You can see it's a feedback object. Here's the grammar to do. Here's the content to do. Here's the style to do. And we also have those scores in the end. So I can easily say trash is going to be 9. And if I should name this one, so let me name it feedback. And now I would say if feedback dot grammar score is greater than or equal to trash, and feedback dot content score is greater than or equal to trash, and feedback dot style score is greater than or equal to trash, in that case, just print feedback is good enough, stopping, and break the process. Okay, but still I want to have this input to make sure I'm aware of every little process, every little step. So, okay, let's run the code. I should stop the previous one. Okay, this is the writer output. And you see, this is a Critic output, and since all of the scores are above 9, it even didn't reach here, the input statement. It just said, okay, feedback is good enough, stopping. Well, for example, I can have a much strict condition. I can say only stop when all of the scores are 10 out of 10. It might take a long time until we have such output, but let's see a few iterations just to make sure everything works. Yeah, now we reach here because this condition was not met, and you see even the content score is 8 now, and I go to the next iteration. Now all of them are 9. I can continue. And again, all of them are 9. So this can go on for a long time, or either I can be more specific in my instructions. I can exactly make the critic to look for certain aspects, certain criteria. Right now, you see it's too vague. It's general. I just say on content, on grammar, on style. I haven't specified what aspects of style or what aspects of content, but still it's good. You see, the result is satisfactory. And now the only thing I would like to say is how we're going to log the result, to log the process, the flow. So OpenAI has this trace built-in function. It's a content manager. So I can easily say a context manager, sorry. I can easily say, I can wrap this code inside a trace, and I can name it. I'll name it YouTube writer. And I just need to shift all of this one tap, and I'm good to go. So again, let's see. Okay, this is the writer's first draft. And here's the critic feedback. I'll run it for 3 iterations, for example. Okay. Okay. So right now I had some flow in my agents. I can go to platform.openai.com, and we have a dashboard here. And we have these traces, and inside the traces I have YouTube writer, you see. Let me click on that. Okay. So you can see all of the processes, I mean the flow for each of the agents. So here's the writer agent, and here's its packet. So, okay, the model is O3 mini. I worked with approximately 300 tokens. It took this time, and here's the instruction for this agent. Here's the input from the user, and here's the output. And you can see here's the critic traffic. This is the instructions, and this is a history. I mean, this is the input list that we provided here, since it was a list of tier response input objects. So you can see from the beginning, this was the user input, this was the assistant. So whatever the agent returns, the role is going to be assistant. And here's the final output. Again, we have the writer, and we have the assistant response. And you see, we have all the history inside the input. So one disadvantage of this way is that, let's take a look at the number of tokens from the beginning. approximately 300, then 700, then again 700, and then 900, because we're concatenating all of the previous chats. So the longer we go on, the larger will be the token list, the number of tokens, and it will cost us more. So this is somehow a disadvantage of this way. One particular way to tackle this problem is to always use another cheap agent to summarize the history, and then just use less amount of tokens. But for this kind of application that we only use roughly around 1000 tokens, it's fine. So I hope you enjoyed this video, and I strongly encourage you to do the same project yourself from scratch without consulting, without looking frequently in the video. So if you can do this, then congratulations. You can do some real-world agentic examples. And until the next video, take care.